x cube minus 3x square plus 4x minus 8 divided by x square minus 3x plus 2 whole square. Now we have to resolve this into partial fractions. First, let's understand x square minus 3x plus 2 can be further reduced, or is it a quadratic function, or it can be made into two linear functions. We understand that x square minus 3x plus 2 can be factorized as x minus 1 into x minus 2. So the given problem will become x cube minus 3x square plus 4x minus 8 divided by x minus 1 whole square into x minus 2 whole square. Now, since we have repeated linear fractions, we can write it as a by x minus 1 plus b by x minus 1 whole square plus c by x minus 2 plus d by x minus 2 whole square. Now let us try to take LCM here and try to get the numerator on left hand side and right hand side. Left hand side will be as it is, right hand side will be a into x minus 1 into x minus 2 whole square plus b into x minus 2 whole square plus c into x minus 2 into x minus 1 whole square plus d into x minus 1 whole square. Now before we expanding, we'll just try to plug in some values and try to get the values of b and d here. Let x equals to 1. In that case, a, c, d will cancel out, b will be left out. Left hand side will have minus 6 and right hand side will be equals to b. So from that, we will get b equals to minus 6. Next, let us plug in the value of x as 2. Let x equals to 2. We'll have 8 minus 8 cancel, minus 12 plus 4. Left hand side will be minus 8. And that is equals to ABC will cancel, only d will be left out. That will be d into 2 minus 1 whole square. So that will give us d equals to minus 4. So we got value of b as minus 6 and d as minus 4. We need to get AC values. For that we have to compare the quotients of x cube, x square, or x or constant term, any two of them. So let us go back and expand whatever we have written earlier, so that when we compare the quotient of x cube and x square, it will be easy for us. So we will write down x cube minus 3x square plus 4x minus 8 equals to a into x minus 1 into x minus 2 whole square can be written as x square minus 4x plus 4 plus b into x minus 2 whole square, that is x square minus 4x plus 4 plus c into x minus 2 into x minus 1 whole square can be written as x square minus 2x plus 1 plus d into x square minus 2x plus 1. Now let us compare the quotients of x cube and x square here. Let us first compare the quotients of x cube. From the left hand side, quotient of x cube is equals to 1, and from the right hand side, we will be getting x cube terms from a and c. So that will be a plus c equals to 1. One condition we got in terms of A and C, that A plus C equals to 1. Now let us see if you can get another condition in A and C so that we can use pair of linear equation in two variables. We can use elimination method and we can find out the values of A and C. Let us compare the quotient of x square now. When we compare the quotient of x square, from the left hand side we will have minus 3. Minus 3 equals to right hand side a into minus 4 minus 4a minus a plus b minus 2c plus d. What are we trying to do here? Get all the terms which will be in x square, and we are trying to compare the quotients. When we do that, we get minus 3 equals to minus 5a minus 4c plus b plus d. We can plug in the values of b and d as minus 6 and minus 4. We will get minus 5a minus 4c equals to 7. Now we know that a plus c equals to 1 and minus 5a minus 4c is 7. Why can't we multiply a plus c equals to 1 with 4 so that we can cancel c terms, c variable? So we will have 4a plus 4c equals to 4. And we also have minus 5a minus 4c equals to 7. Adding them, we will get c cancel out. We get minus a equals to 11 or a equals to minus 11. But remember, we also know that a plus c equals to 1. That means c should be 12 because a plus c is 11, a is already minus 11. So c should be 12, then only a plus c equals to 1. So we got the values of a as minus 11, b we got it as minus 6, c is 12 and d is minus 4. Now it is the right time to go back and substitute the values of a, b, c, d so that we can write them in partial fractions. So the final answer will be minus 11 by x minus 1 minus 6 by x minus 1 whole square plus 12 by x minus 2 minus 4 by x minus 2 whole square. Now let's just try to summarize what we have done. We observed that the denominator x square minus 3x plus 2 can be factorized further, and we realized we are going into the type of the problem where we have repeated linear fractions. So we have written it as a by x minus 1 plus b by x minus 1 whole square plus c by x minus 2 plus d by x minus 2 whole square. First we plugged in the values for x equals to 1 and 2. We are able to get the values of b and d. Then we compare the quotients of x